Hey everybody. Today we're talking about marginal probability distributions of continuous random variables. We're in a situation where we've got a couple of continuous random variables, say x and y, defined by a joint probability density function, a joint PDF, f of x comma y for short. And we know in a situation like this we can compute probabilities using multiple integration. For any subset d of r squared, the probability that x comma y is in D, is in that region, is given by the double integral of the PDF over that region. We can also consider variables separately, considering probabilities just for x or just for y, and these are called marginal distributions. As with the discrete random variable case, we call the probability functions f sub x and f sub y. In each case, we get the marginal PDF by integrating with respect to the opposite variable, essentially integrating it out. So f sub x of x, the marginal probability density function for x, is given by the integral from negative infinity to infinity f of x comma y dy. So when you do that integral, you treat x as a constant. That means that the output is still going to have x's left in it. Hence, f sub x of x is actually a function of x. Similar things for f sub y of y. Let's do an example. Suppose we have two continuous random variables, x and y, and their joint PDF is 1/16 x plus 3y. And the support is 0, 2 cross 0, 2. So both x and y are only defined between 0 and 2. The probability is going to be 0 elsewhere. The probability density, that is. I want to find both marginal PDFs, and I want to use them to compute a couple of probabilities. Let's start with f sub x of x, the marginal probability for x. Again, that means integrating with respect to y over the entire support. So I'm going to integrate from 0 to 2 of that PDF dy. I get an antiderivative with respect to y, treating x as a constant, plug in my limits of integration, and I get x plus 3 over 8. Similarly, f sub y of y is going to be obtained by integrating from x equals 0 to x equals 2. Now I do my antiderivative with respect to x, plug in x equals 0, x equals 2, and this time I get the marginal PDF of 3y plus 1 over 8. Each of these PDFs is a legitimate PDF in its own right, and that means they're greater than or equal to 0 everywhere, and each of them integrates to 1. And you should check that. If you integrate either one of the PDFs at the top of the screen here, from 0 to 2, in fact, you get 1. Okay, let's actually use these two marginal PDFs we got to compute a couple of probabilities. The probability that x is less than 1 is obtained just by integrating that marginal probability function with respect to x from x equals 0 to x equals 1. And that is the part of the support that corresponds to x less than 1. When we do that integral, we get 7/16. Similarly, to do the probability that y is greater than 1, we integrate f sub y of y from y equals 1 to y equals 2. Again, that's the part of the support corresponding to y greater than 1. When we do that integral, we get 11/16.